all the viewer and our respected student. We are from Group 18 are going to present you about our case study for discrete mathematics in this video. Before we into our topic, let me introduce you to our group member. First one, for leading the group as the group manager is me, Muhammad Rizal Mekarik, A22135 and 1, bringing exceptional organizational skill and strategic thinking to the table. Second, working alongside with me is Muhammad Iram Aidid, bin Muhammad Sidi, AA2049 and 6, our talented graph visualization specialist. We also have a Ko Amir Hafiz bin Ko Asmawi, AA20938, a meticulous editor for our work. Supporting the team is Muhammad Syakban Baks bin Rahman Baks, AA21671 as an analyst, and lastly, we have Muhammad Isham Aziz bin Muhammad Rasul, AA22169, our skill report writer. So for our life problem, which is to talk about the problem that courier service encounter. That is to finding the shortest path for a courier to deliver goods from the current location to the desired destination. To solve this problem, we can use a weighted graph where location are represented as nodes, path as edge, and distance represented as way. So by utilizing this graph representation, we can determine the most efficient route for couriers.
Based on the problem statement, so the type of graph that we choose to solve this real life problem is weighted graph. Weighted graph is a graph where every single edges that connect within a vertex, there is a value on it. So I will show you an example. So the tool that we use to create graph is Graph Online. So how to use this graph is you can add a vertex in here. This is how you can add a vertex, and this is how you can connect each vertex. Each connection that you create is what you call the edges. So you can also put a value on every single edges that you connect. For example, I put 4 in here, and as you can see right now, there are the edges and there are a value on it. So this is what it means, a weighted graph. A graph where there is a value on every single edges that were created. So you can connect more edges if you want. So what is the difference between undirected and directed? If you click directed, there will be an arrow on it, but if you don't, then there will be no arrow. So that's the difference. So you can just add more. So that's how you create a graph. So this is how our graph looks like based on the real life problem that we created. So this is it. You can also rename every single vertex in here. How to rename it? Just click right and rename a vertex. So for this one, I will rename Bandaraya Melaka, for example. Okay, so this is how you can rename the vertex. So that's all. Thank you. Okay, so I will demonstrate how this graph works. So this is how our graph looks like. So as you can see right now, there are 1, 2, 3, 4, 5, 6, 7. There are 7 vertex in this graph, and there are so many edges in this graph as well. So as you can see, every single edges has their own value. From A to E is 2 kilometer. From E to B is 2 kilometer. Every single value they represent in every single edges can be initialized as kilometer. So the first destination, which is where the courier's at, is A. So the courier will deliver the item to the customer, which is the last destination. So the last destination will be G. G is where the customer's at. So the courier must walk through every single vertex only once before reaching the last destination, which is G.
Okay, Assalamualaikum. So, for me, I will describe for the graph for its vertices and edges. So, as we can see right here, for the graph, we got 5 vertices and 10 edges. So, let me list the vertices of the graph. So, we got vertex number 1, vertex number 3, vertex number 2, vertex number 0, and vertex number 4. For the edges, there are 10, which are the weight of the edge is 3, 7, 2, 6, 6, 1, and 5. So let me explain more detail about the graph. So for vertex number 1, there it connects vertex number 4 and vertex number 3. So from 1 to 3, the weight of the edge is 3, and from 1 to 4, the edge weight is 6. So So next, we go to the next vertex, which is 3. Um, it connects to the vertex number 4 only, with the width of edges is 5. And then we go to the vertex number 0, which connects to 3 vertices, which is vertex number 1, number 3, and number 2. From vertex 1 to from vertex 0, from vertex 0 to number 1, the width of the edge is 2, 0 to 3 is 7, 0 to 2 is 6. So next to the next vertices, we got the vertex number 2, which only connects to vertex number 4. So it only, the width of the edge is 1. So for the last vertex, we got 4 that was connected by the vertex number 1 and number 3 previously. And I have stated that the width of the edges before. So I guess that's all for my explanation. Let's move to the next step.
I'll be presenting our step algorithm, and for the first step is we need to define the problem, and the definition of the problem is to determine the shortest path for the courier to deliver goods from the current location to the destination F. Step 2 is to devise a plan, and the first step is to list all possible routes to go to G and calculate and compare the distance of each route to find the shortest path. Next, we need to carry out the plan. So the plan is to calculate each distance for each route. So for route A to route E to route B, route D, route F, route C, and to G. So same with the other route, and we get the output of how many kilometers there are. And then we compare the route and look at which is the shortest route to go through. And the bottom line is route D is the shortest route in the network graph, and it is 22 kilometers to reach G.
Now, we're reaching the final part of our presentation today, which is the conclusion for our study case. In conclusion, using a weighted graph to find the shortest path for a courier at the current location to deliver goods to the desired locations involve a methodologies that include defining the graph, assigning weight to the edges, choosing the right algorithm, implementing the algorithm, and finally, evaluating the solutions. By following the methodology, courier service will be able to improve the efficiency, reduce costs and time needed for delivery, and manage the services they provide the customer effectively. That's all for our presentation today. Thank you.